Hungry for gold, they came west and picked at a mountain with a hide as tough as steel. But with broken picks, they turned away to look elsewhere. And they left behind the forgotten ore of Eagle Mountain. This is the story of a mountain of iron ore in Southern California, left behind by the early day prospectors because the West of the past century did not yet know how to put this mountain to work. This is iron ore, brownish red, rugged, heavy. It has no gold in it, no precious metals, but it could be called the foundation stone for the building of the West, because iron ore is the stuff from which steel is made, and steel is everywhere around us. It's in your home, freeways, automobiles, office buildings, heavy, massive steel to stand forever, steel to bring you comfort, glittering and keen, graceful, delicate. And this is the story of how steel is made in the West from the forgotten ore of Eagle Mountain. More than 20,000 tons of ore and rock are blasted loose each day, scooped up and loaded into trucks. Huge trucks, specially designed for work in this mine, the biggest deposit of iron ore on the Pacific coast. Men keep the mountain moving, men with machines and know-how. Conveyor belts move the ore along into a processing plant where the rock and other waste matter is taken out. Machines with steel jaws smash the big chunks into pieces as small as marbles. The high-quality ore streams out the other side, ready for loading. Carload after carload rolling across the sun-baked Southern California desert. 160 miles to the steel plant at Fontana, one of the shortest iron ore hauls in the country. Important as iron ore is, however, there are two other raw materials needed to make steel. One of these is coal. Not just any coal. It takes a special quality. It is estimated that less than 10% of the coal in the United States is suitable for use in making steel. An abundant supply of this material is found in the mountains near Raton, New Mexico, another vast deposit in the rugged crags near Sunnyside, Utah. Men with lamps, hard hats, and muscle go deep underground to dig out the shiny black treasure. Miles from sunlight, Machines with steel claws rip the coal from the face of the mine and load it for the trip out. Coal, buried for millions of years beneath the weight of a mountain, brought out now to serve the needs of modern man. The loaded mine cars are nudged into a sturdy rotary dumper and emptied one by one onto a conveyor belt below. The coal is funneled swiftly through a process of crushing, washing, blending, then loaded into railroad cars for the trip to the steel plant. The third raw material, gleaming white limestone, is found at Cushenberry, California, in the San Bernardino Mountains. The operation is much like that at the iron ore mine. Power shovels to trucks to conveyor belts. Limestone, coal, iron ore. Trainloads of raw materials rolling to the steel plant at Fontana, 45 miles east of Los Angeles. Here is the biggest steel plant west of the Mississippi, where modern mills and machinery change the raw materials into finished steel shapes. First stop for the coal is a rotary dumper, where the gondolas are turned upside down and their 65-ton cargoes are emptied. The next stop, this battery of coke ovens, like a row of tall books, each one only 14 inches wide, standing side by side. Through holes at the top, the coal is poured in, then baked at 2,000 degrees for 17 hours. The intense heat causes the coal to release certain vapors. These are piped into a complex system nearby for the recovery of valuable byproducts, which are used, believe it or not, in the manufacture of perfume, plastics, aspirin, synthetic rubber, paints, and many other familiar items. Almost pure carbon now and called coke. The fiery material is pushed out of the oven and into a waiting hot car. Water is poured on the coke to keep it from consuming itself in flames. The coke is now ready for the blast furnace, where it is mixed with the other two raw materials, iron ore and limestone. In a continuous operation, night and day, a skip car dumps measured quantities of the three raw materials into the top of the huge furnace. A blast of superheated air blown in at the bottom ignites the coke. Tremendous amounts of gas released by the burning coke combine with oxygen in the iron ore and convert the ore to metal. The metal melts, runs down to the bottom of the furnace, and forms a molten pool, 2,650 degrees Fahrenheit. In the meantime, the limestone also melts and runs down. It combines with waste matter in the pool and floats to the top. This layer of waste material, called slag, is drawn off from the furnace at regular intervals. When 250 tons of molten metal have been collected in the bottom of the furnace, a clay plug is removed, and a flaming river runs down a shallow trough. The fiery metal pours into the mouth of a specially designed railroad car lined with fire brick. This is not steel, remember. This is molten pig iron. As milk must be churned to make butter, pig iron must be further refined to make steel. There are several ways of refining pig iron into steel. One is the open hearth method. The open hearth furnace is charged with steel scrap, limestone, and small quantities of iron ore. Oil or gas flame burners heat the mixture until it is nearly melted. Then comes the principal ingredient, molten pig iron from the blast furnace. The mixture bubbles inside the furnace for approximately 7 hours, a complex physical and chemical process, reducing the carbon content, refining it into high-quality steel. Operation of big furnaces produces a certain amount of smoke and fumes. To minimize this at the Fontana plant, engineers designed a number of control devices called electrostatic precipitators. This is how the open hearth building looked before the precipitators were installed. This is how it looks today. When the molten steel meets exacting specifications, the furnace is emptied. Steel, 250 tons of it. The open hearth furnace has been the reliable workhorse of the steel industry for many years. But there's another method, a way to make steel in minutes instead of hours. That's the oxygen steel process. Into a huge brick-lined vessel tipped to one side by powerful motors, you pour a ladleful of molten pig iron. Then you add a load of high-quality steel scrap